All right, round two. Jeez Louise. You can do it. Nice. 12. And let's say this is cool. So kind of a simple problem set up here. It's just like a like a ratio problem. That's gonna be number one, and then number two will be right here. Oh, really? I didn't get your get your email, Tony. Let me check that. Tony. Nice. You made this practice test? Where's this practice test from? Very interesting stuff, man. Yeah, it's very interesting. I've never seen this before. Huh. Cool stuff, man. Nice. Nice. Nothing from books, so you made it, huh? Interesting. Very cool stuff, man. Very, very cool stuff. I can't wait to get a second to check it out. Yeah, definitely, definitely. What inspired you to make it? Were you just feeling like motivated? That's cool, man. Wow, super cool, man. Yeah, that's awesome. Well, you're a smart kid putting together practice tests. That's cool. That's cool stuff. Yeah, and I'm stoked for your score too. That's exciting. Well, since you like math so much, let me give you a math problem that I think might stump you a little bit. 563. Yeah, that's legit, dude. That's great. That's super solid. Let's see here. How am I gonna do you? Let's see. Ah, I got something. Well, yeah, I don't want to do rate. Okay, this was good. All right, let me make it even bigger. All right, so we got a beautiful circle here. Nice. Here's the center of the circle, right there. Let's say we have a line that goes here. We have a line that goes here. And then we have a line that goes here. And a line that goes here. Bang, right here. Bang, right here. Bang, right here. And let's say that this is, that would be okay, so let's say that this is 40. And let's say, I need paper. Bring it on, or paper. Isosceles triangle. You know it? Oh, good man. Good man. Well, then hit me up with the answer really quick if you know it. These are our two angle measurements. I want to know what X degree is in there. With the radioled on? That's funny. You got it yet, Tony? Tony Ainsley. $80. No, that is incorrect. Double check your math to make sure that you got everything locked in there, my man. Double check that math. All right, I got the next one on deck for whenever you're done with this first one. 120. You're inching closer there. So, my guess is, since you said radii and since you said isosceles triangle, is that you are correctly seeing that this right here is also a radius. So now we got a triangle here that's isosceles, or I'm sorry, that is a radius and a radius, and we have a radius and a radius there, right? Yeah, that's it. Tony, that's my man. You got it. 140. Exactly. Because the best 40 makes that side, this 40 makes that side, leaving us 100 in here. And then we do the same thing over with the 70, making that and making this, and we get 40 over here. That whole thing, 140. Nice. Dude, you got to add right. Dude, I call those serious mistakes, because if you were a mechanic and you like forgot to tighten a bolt and it fell apart, that would be like super serious. Okay, so here we have a map, bird's eye view. We got city streets, and the lengths of the city streets are labeled there for you. And I want to know how much shorter, I wrote shorty because that's when you got the answer, I think, or something, I forgot. So how much shorter is taking the highway than taking those city streets? And for the sake of argument here, let's just clarify that we got some right triangle action. Yeah, so the entire green is a highway that cuts through the city. And if you were just to take the city streets, you'd have to go through the blocks like this. And this is 4 miles, this is 12 miles, and this is 5 miles to get there. Or you could just take the highway, bang. I want to know how much shorter or how many less miles you travel taking that highway. How you doing over there, Tony? You got this answer already, homie? Is your brain exploding? Is like your brain expanding and contracting about this? Oh, your computer died. Okay. I'm holding on, dude. I'm into anticipation. I know you got this, my man. What is in your hand? Is it a decimal answer? No, it is not a decimal answer, actually. It works out pretty clean here. $18. So you're actually very, very close. You're in the ballpark. So that means you have a good conceptualization of this problem. So what we recognize we have here is two right triangles. And with Pythagorean theorem, just a quick reminder, I'm sure you already have this in your head somewhere. That's what we're going to be using to solve this. And this requires that we have two sides to get the hypotenuse. And we don't have two sides here. We just have one side, and then we know the entire length, but we don't know how much each of these is worth. And we have one leg here, so we don't have enough. But you can also reimagine this problem. Like, for example, what if I were to redraw it like this? So originally it looks like this, and like this, and like this, and we have the green highway cutting across like that. But what if I took this length, and instead of walking over here and taking a left, or walking over here and taking a left, what if I just started walking and I just held off taking my left turn until later, and then I took my left turn here, right? It's going to be the same distance, except now we're getting a triangle that we can work with here. And so since this is 5 and this is 4, this will also be 5, and this is 12. So really down here what we have is 9, 12, and we need to solve for C right there. And that's the length of the highway. So, what's our answer, homie? I give you everything. You don't get everything. You only get some things. Bang. Right on cue. Perfect answer. That's right. So the highway is 15. So, I mean, to answer the question, what's our answer for the question here? How many miles shorter is the highway? You made a proportion. Yeah, that can, I mean, that's a really good strategy. That's a super good strategy, actually. But, you know, even the best strategies, sometimes you play it out, and you don't get the right place, but it's like, well, at least you tried, you know, at least you put some good work in. But you're totally right. Okay, so so what high school are you going to, Tony? What high school did you get into? This is the next one, by the way. Let me see if I can get a little bit closer so you guys can read it better. That's what I'm talking about. All right. Oh, Staten Island Tech. Nice, dude. Nice. I live in Queens, but I'm on the road right now. I'm on the road. I'm currently in beautiful California. All right, dude. So we have a probability one, and this is like a real world probability because it's like if I said like playing this game cost, let's say, $50, which is pretty expensive for one roll of the dice, right? Would it really be worth it? Do you have a chance to get this $45 billion payout? You got to think, is it worth it? Give it a shot. Is it 1 over 6 to the fourth? If not, I may have the answer. Okay, so very interesting how you expressed your response. So, what you're saying is 1 over 6 to the fourth, right? So, what else do you think it could be if it's not that? Yo, what up, Bob, man? Just doing some math. And Tony actually just finished crushing this problem. And I want to tell you, I mean, I was interested to see what else you would have got as a solution. But this is right, dude. Because if you think about a coin flip, 2 in a row, that's 1/2 probability, 1/2 probability, and you multiply them together. And so, yeah, this is like saying multiplying the probability 4 times because you have that 4 dice. I really like how you expressed that. That is nice. Okay, so let's move on to the next one. See, I get a piece of paper here. All right. List calls for 5 parts sugar, 4 parts lemon, and what did I get on the SAT? I actually didn't take the SAT. And 4 parts, or SHSAT. Did you ask for the SAT? Yeah, I didn't SAT. I didn't grow up in New York. I just moved there after school, actually. 4 parts lemon and lemon parts. Oh, Botman. Yeah, and 11 parts. Salt. We need Staten Island Tech, boy. Bang. Fine. Botman, that's a solid score too, my man. You win standardized. Oh, JK. Didn't take it. Dude, right off the rip. Very nice, Tony. I gotta start giving you harder problems. That is correct, dude. Very, very nice. All right, I gotta give you a harder problem, dude. You're crushing too hard. You're crushing the math too hard, my man. Let's see. Piece of paper. Here we go. Do you see through that? No, we good. So let's see here. I gotta give you something really wicked, man. Really wicked. Okay, here's one that I don't show that often, but it's a good one. Yeah, I come off straight off the dome, dude. Always, always, always. Okay. Here's a problem for you, my man. What's the answer? Yeah, that's right. Call it like you see it, man. Yeah, it's a logic problem. See. Oh, wow. Yes, sir. Yes, sir. Well done. Well done, dude. Well done. All right, dude. Gotta keep it coming, man. You keep being so you're on a roll, man. You're like heating up. All right. This is gonna throw you, dude. This is gonna throw you. You're gonna be like, I thought I was good at math. I'm gonna give up math after this problem. You're just gonna be like, no way. All right, hold on. It's gonna get less blurry. Okay. Okay. So, perimeter of the fencing is, let's see here. I gotta do some quick math. So let's say, what is? That would be. All right, I got you, dude. This is gonna be it. So we got a fence up against a wall. We got some right angles going on here. So the wall, and then I just bought some fencing, and I put the fencing down. And I bought 100 feet of the fencing, so it's 100 feet all the way around. I want the pen to be 1,200 square feet. What could be possible dimensions of that fence? This is a stumper. Absolute stumper. Good luck. 60 by 20. Hey, 60 by 20. That is correct. Wow, that was fast. Botman, well done, my man. Well done. Did you get that by guess and checking, or did you get that by using algebra? Hold on. We have another entry to do it the foray. And I will say there might be two possible answers here. I'm not against that. Quadratic equations. Yeah. You used algebra, Botman? No, you did not. No, you did not. What did you do? How did you do the algebra that quickly? Yes. Yes. Yes, I did. Dang, dude. That's fast. That's fast. And the quadratic equation, actually, Tony will also get you that as well. That's kind of how this bad boy rolls. Because if this is your x and this is your y, then this will also be x, and we know that 2x plus y will equal 100. We also know that x times y will equal 1200, and here are our two equations that we can play with as a system of equations. You're in the middle of solving it? Yeah, dude. Botman with the win. That is fast, my man. That is really fast. I know you did it too fast. Maybe Botman is an AI. Maybe he's literally a robot who just crawls around YouTube to answer math problems ridiculously fast. So let me see if I can get something else that might give you a little bit of work there, dude. Let's see here. It's got to be a stumper, man. It's got to be a good one. I got to reach deep in the old well here. Okay, here we go. Circle problems, dude. All day, every day. Okay. It was going so good until I messed it up. All right, that's our beautiful circle here. Let's say we have a nice angle in here. That's just horrible. I'm gonna draw a new one. I hate that circle. Hold on. Much better. Great. Okay. Way better. All right. Whoa, Illuminati spotted. Okay, hold on. So we have this here and this here. If this is 6 right there, and let's say that this chunk right in here, that'd be, hold on, let me math my head. Hold on. Okay, so this would be 2. No, I hate arcs. Oh, my kryptonite. Well, then you're gonna learn them, dude. You know, that's like a Michael Jordan quote. He said, take my weakness and I'm gonna make it my strength. And then he would just boss people where he used to be weak. Okay, cool. So what I wanna know is fire up the analytics, bot man. Here we go. This is a circle. I wanna know X degrees. Oh, nah. Come on, dude. Put it through your advanced AI, bro. You can do this. Dude, robots don't have any feelings. You can't actually hate this. Give it a shot, and then I'm going to show you guys how to do these problems. So easy, dude. These problems are, once you get this little trick, this little secret, you're going to be like blown away, bro. I'm going to show you how to do circle problems like this so fast, dude. You're going to love circle problems after this. You're going to be like, can we do more? You're just going to be like, where are all the circle problems? Bangarang. All right. How you guys doing? You guys doing all right? Are you dying on the inside? Do you just want the pain to go away? Okay. Alrighty. I'll give you more time. Yeah, it's Tony. It's just extra fancy. Extra fancy. Tony. 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 What's up, Aisha? What's cracking? Doing some math. This is a hard problem, though. That's for sure. All right, dudes, I'm going to show you how to do this. And forever, you're going to know how to do circle problems. So the way you need to think of like arc problems or interior angle of a circle problem is as if you had like a delicious looking pizza like that. And let's just say that it's like kind of a smaller pizza, so they cut it into 4 slices, right? So that means that each person gets 1/4 of the pizza, and that's going to be very important to know to establish this, and we're going to see why. So if I gave you 1 slice, I'd be giving you 1/4 of the pizza, aka I'd be giving you 1/4 of the entire area. I also would be giving you 1/4 of the crust, aka 1/4 of the circumference. I would also be giving you 1/4 of the interior angle, right? And that would equal 90 degrees because 1/4 of 360 is 90. 90 times 4 equals 360, right? So these are all 90-degree angles. So that's how you can solve this one, is you got to find this ratio. What percentage of the crust am I giving away? And then you can find what percentage of the interior angle away. See if that hint helps you guys out. And Aisha, what are you working on? Are you working on math? Are you working on ELA? Are you studying? Have you taken the test? Working on my math. Nice, nice, nice. Can you repeat one more time? No problem, dude. That's what I'm here for. So, let me give you this. So remember, you're giving away, this ratio is important because if you can decide, oh, I'm giving away 1/4 of the pizza, that means you're giving away a fourth of the circumference. That means you're giving away a fourth of the interior angle. So you have to ask yourself now, well, we know this is 2 pi. What percentage of the entire circumference is that? Is it a fourth? Well, we need to know what the entire circumference is to figure out what part this 2 pi is. And then once we know, let's say it's a third or something, then we know that this interior angle is a third. Oh my gosh. All right, Aisha, I got a math problem coming for you because this is starting on, you're not stupid, dude. This is starting on like high level math. I want to give you something. Let's see here. I'm up for it. Nice. All right, I'm cooking it up right now. Can you smell it? Because it's coming. And this is going to be an Aisha exclusive problem. All right. So, while Anthony and our resident robot work on this circle problem, I want you to answer this for me, Aisha only. And let me actually fold this down. Now, I know the robot can put it through his system and answer this, and I know Anthony could probably answer this. This is Aisha only. All right, let me make it so it doesn't look crappy. There we go. Nice. All right, girl. Yeah, but don't say the answer yet. It's for Aisha. It's not for you, Bot Man. You're a robot. Go back to your circle problem, robot. $50. And how did you get that? Well, I'm sure you just found the mean. That's how you got that. But great job. That's exactly correct. The answer is 50. Well done. Yeah. Divided by 5. You mean divided by 4? I know what you mean. I know what you're talking about. Okay. I know what you're talking about. I know you meant 4. I know. All right, let me give you, I'm cooking another problem for both you guys. Hopefully you guys can finish this circle problem already so we can take it down. That'd be lovely. Think. 20. Done. I think. The answer is, I don't get it. Okay, cool. Let me break this down. So here is our radius, right? Really quick, first person, tell me what is the equation from getting a radius to getting a circumference? How do we go from radius to circumference? What would be our circumference in this problem? You guys remember the equation? It is 2 pi. Yep. Aisha with the win. It is 2 pi r. So what is our circumference here? Exactly, 12 pi. So the entire way around this is 12 pi. Great. So what is this piece? This piece is 2 pi. So think of our part over the whole, which would mean that we have 2 pi over 12 pi. because this is the part we're giving away and this is the whole, right? So this would reduce to 1/6. Yeah? So my question to you now is, if this entire interior angle equals 360, yeah, Tony, that's it, my man. This is going to be 1/6 of 360, aka 60. Hot. Hot answer. Very nice. Very, very, very nice. Okay. So the next thing I want from you is a perimeter. Assume all the angles are right. Oh, you calculated area? Oh, yeah, that'll make a big difference. Okay, so here we go. I don't know what I was doing. That describes the way I handled most of life, dude. It's at least you were trying, bro. That's all that matters. That's all that matters. So this isn't, of course, is not drawn to scale. It's actually really poorly drawn. I'll admit that. I'm gonna label this poorly drawn because it is. It's just not. It's just lame. Okay, so I want to know what is the perimeter, and I always misspell this, but whatever. What is the perimeter of this shape? Well, and assume that I guess all of these are just right angles, of course. Mm-hmm. 41. Incorrect. Incorrect. What? Yeah, incorrect. I'm rushing, that's the problem. Yeah, dude. Aisha, 45. That is incorrect. Incorrect. So we know it's not 40. Let's see. It's not 41. It's not 45. Let's see what else we got here. Don't say it. I'm not going to. I'm not going to say it. I will never say it. I'm not. I'm literally going to keep this live stream open until one of you guys solves it. Even if that's the rest of my life, I'm that committed. I gotta make sure I did this math right. Let's see here. And remember, it's poorly drawn. That's why I labeled it. '68. Incorrect. Incorrect. It is not 68. What? 42. Incorrect. It is not 42. I didn't realize this was so tricky. All right, just a couple more minutes and then I'm going to show you how this is done. Yeah. 40. The length on the far left. 6 is the whole side. Yeah, this is all 1/6. That's all 6. 44. No, that is not it. 40. That is not it. 44. Nah. No. So, okay, guys, I'm going to show you how to do this. Maybe one of you guys is right. Maybe I made a mistake. It happens. I'm open to the possibility. So, this is what I got going on inside my head when I this. Okay. What's the question? Jonathan, what's up, man? Late entry. We're looking for the perimeter on this bad boy. But I was actually about to show these fools how to, or not fools, just actually pretty solid students. I'm about to show these guys how to do this one. So, looking at the top here, right? This whole thing has to add up to 12 because this whole thing is 12, yeah? And so, well, we can look at this. It's 3 from here to here is 4. And so we need to add up to 12. And so this is actually 5 right there because that whole top needs to add up to 12. Okay? So then we have to do the same thing for the other side, right? So we know, let's look at this side very quickly, right? Oh no, I forgot that. Oh no! Yeah, so from here down is actually 3. And this is 3 here. That's why I kept saying it's like poorly drawn, right? Because we know that this is 3 and this is like a square right here. And so since this whole thing is 6, this bottom half has to be 3. Oh, yeah, boy. And so what you do is then to get this long side, well, we know from here to here is 5. And looking straight across, we know that from here to here, because it goes up 3, then down 3, so it's straight across, we know that this is 3 right here. So this entire side is 8. Yeah. And so then we just add it up. And so it's it would be 5 plus 5 plus 4 plus 3 plus 3 plus 6 plus 12 plus 8. Right? Scoot it up a little bit. This here is 20. Add that in, and it's going to be 26. This is 6. Add that in. That's going to be 32. Add this in. It's going to be 36. These are all old. And then add in 10. It's going to be our answer. 46. That is it. Yeah, Tony. That's what's up. 46. So yeah, that's this problem. It is a tricky one, but you know, just remember it all adds up. All right, dudes. So I'm actually going to bounce out of here. I'm definitely going to be streaming a lot more. I really enjoyed this. You guys did a really awesome job answering this question. It was clickbait. This streaming was clickbait. But yeah, I mean, I'm definitely going to be around to answer like any other questions you guys have later in the weeks and stuff like that. Yeah, exactly. It looked easy, but it was really hard. Yeah, that's a good math problem. That's the sign of a good math problem, because you know math can be really complex, but it also can be super simple. But yeah, man, I had a good time. I had a good time doing some questions with you guys. So definitely smash that like button. That definitely helps me out. And yeah, man, tell your homies about the channel. I'm going to be back to help you guys out with more math and more ELA in the future. All right, dude. So I'm going to sign out. It was super chill. Have an awesome weekend. Email me on the test you made. Yeah. I'll definitely give you a shout out, Tony. Thank you for emailing that to me. It was very, very interesting. Yeah, Aisha, awesome. I'll be seeing you around, man. So I'm happy to help anytime. And if you guys have any questions studying, just shoot me a message or an email or whatever, and boom, I got your back. All right, dudes. So take it easy, and I'll catch you next time.